everyone here also take the lecture on the 6:30 p.m. Okay, 1, 2, 3, 4. Okay, fine, about half. Because there's not too many audience. I'm okay. We can leisurely talk about this topic briefly. Because I will maybe I can go more deeply about this topic at 6:30 p.m. So another half. Oh, no problem. I think I can start it right now. So in this 1 hour talk, I am going to talk about this topic about cold wallet. Professor, it is very honored for me to be invited here by Professor Liao. And this topic is about the cold wallet. So who am I? Actually, just a few years ago, I also studied here in the Fast Crypto Lab. And I am very interested in cryptographic design, system design. And I am currently a cryptographic architecture and engineer at a small startup called Kelvin, which is the team behind this little product, Kelvin Wallet, and which we will talk about it later. So today's agenda, I'm going to talk about very simple, just two topics. How do cryptocurrencies actually work under the hood? But I will not go into too much technical details. And why do we need cold wallets? How do hardware cold wallet works? I will give a brief live demo here later. So the first question is, this is a very important question. Every participant in this blockchain world need to understand. What does it mean to actually own a Bitcoin in a world without any governments, without bank? How do we achieve that? How do we build a cryptocurrency? There are many tutorial, many lecture material on the internet, and here is my few cents on this question. I think a way to view blockchain is that blockchain is just a database. It is a ledger. It is a data structure. And sometimes, most of the time, it is distributed. Inside this ledger data structure, we can record information like account balance. Like this here, we can have a table of all participants and their account balance. In addition to account balance, which is very common to most of the blockchain, we can also have some sort of programmable unit, a smart contract code, and we can assign state to object in this world. And the ledger is mutable. We can mutate the state. For example, here on the left-hand side, there is a ledger state 1, where Alice, Bob, and Carol have $3, $20, and $10. And maybe after some manipulation, after some operations, the world enters another state, ledger state number 2. And their balance might change, though state may be mutated. So blockchain is, we can see it as a ledger. And such ledger, or we can call it a database, it is a transactional database, by which we mean that we can mutate the database state with transaction execution. And there is a very important property of blockchain is that we will have a complete log of all the transactions. We can also think it like an append-only database, where the structure is just a list of all the an ordered list of all transactions that was ever happened, was ever executed in this blockchain. And there is usually another important property where every transaction in this database is digitally signed, which can provide authenticity to each information. And in blockchain, this is the third component. In blockchain, there usually are a set of consensus rules and protocols to help us answer this question. Because everyone can participate, everyone can join into the peer-to-peer network and submit transaction. We need to have a concrete rules specifying which transactions are valid and which are not. Besides validity, we also need to answer the questions. Which transactions should appear first? Which should be executed first? Because obviously, the ordering of transaction execution matters. Maybe Alice wants to transfer some funds to Bob, and after that, Bob can transfer more funds to Carol. So the transaction 1 must happen before transaction 2. Otherwise, the transaction 2 is considered invalid. The word state will change if we execute transactions in different order. So consensus rules and protocol help us maintain a consistent view eventually, so that everyone can see the same state of the system. And in the blockchain world, the digital signature plays a very important role. And here is just a brief diagram showing what it means for something to be digitally signed. Here we have a yellow box. This yellow box is the signing function. When anyone wants to sign a message maybe hello Bob, any message we can view it as a bit string. Anyway, we can view it as a number or a bit string. When we want to sign it, we need to have a private key. So here is a private key, and the signing function takes 2 inputs, the message and the private key, and produce a digital signature. Most of the time, when we refer to digital signature, we are referred to this small parts that looks like a randomly generated numbers. And we will attach this number to the original message. And after that, we say, okay, the message is digitally signed. And what can we do to sign the message? Anyone who wants to verify the function can call another routine called verify, this yellow box. And to do that, this one, so Bob wants to verify the message signed by Alice. He needs to get Alice's public key and fit into this yellow box called verify. And the verify function will generate a 1-bit message, 0 or 1 or true or false, indicating this message's validity. So owning a Bitcoin is basically, in a slightly more technical term, it is defined as being able to spend such Bitcoin. And in order to spend a Bitcoin, we need to generate a transaction, which is just a digitally signed message. And that is being able to sign a transaction. And the ability to sign a transaction is just the ability to control the corresponding private key behind the identity. So if you want to protect your cryptocurrencies, that means you want to protect the private keys behind your money. And there are some ways to do that. Strategy 1, we can rely on others. So this is the traditional banking model, centralized model. We can find some third-party services, like there are many online cryptocurrency exchange, and there are many online web services or online network connected mobile apps where we can sign up for an account and deposit some cryptocurrency, and when we want to use them, we can withdraw some from it. There are many of these kinds of service. And there are pros and cons. The pros are, such services are mostly very easy to use. But there are also some cons. For example, we lose the actual control over the funds, because if the private key get lost or maybe the service get hacked, the corresponding cryptocurrency can be easily accessed by the attacker. And we are heavily rely on other service, other people to manage all this complexity. And every year, every month, we can see there are many news about online services like this get hacked. For example, this happens just a few months ago. There are a few cryptocurrency exchange get hacked by sophisticated phishing attack with Firefox zero-day vulnerability, where attacker launch a very sophisticated attack that abuse the vulnerability of the browser. And there are some attack. The Binance is a very large cryptocurrency exchange, and it has been attacked many times too. Other than relying on others, there is also another strategy, which is we can do it by ourselves. Maybe we can just write down the private key on a paper and protect that piece of paper by ourselves. Or maybe we can have a USB flash drive, or we can have a air-gapped laptop, air-gapped PC, and air-gapped Raspberry Pi, the smaller PC. And we can install some desktop or mobile software on our own devices to manage all of that, where we can generate our own private key, manage our own backups. And in some solutions, there may be extra hardware devices that provides backups or provides more security features. And more importantly, most of this mechanism require memorizing passwords, memorizing pins. There we need to memorize some secret information in our brain. And there are pros and cons. The pro is that we can actually fully control all the funds, all the private keys behind our digital currencies. But the big problem is that, so now we need to take full responsibility when any things go wrong. And the use case is very much like a safe box. We can put our own money, put our own gold stick into our own safe box. But when the box go wrong, or when the box gets stolen, we need to take our own responsibility, because no other people can help us. No bank can help us to manage this. It is our own responsibility. And if we want to do that, there are already many solutions, like cryptocurrency cold wallet. There are some very popular ones, like the one from Tracer and the one from Ledger. There are very popular vendors for such hardware devices. And if you go to their website, you can see what they look like. For example, the Ledger company, they provide products that look like this. This is a small device that has two buttons. This is button 1, this is button 2, and it has a small display on the hardware. and the connectivity of this device is majorly the USB cable, but also it also have wireless connection. Okay, and there is another vendor called Tracer that does very similar things. And when I saw these products, because I am very interested in security, cryptography, and real engineering challenge, so I want to do the same products by our own. So we built a small team to do so, and this is our result. The result, if you are interested, you can later come here and see the actual products. This is just a small device which can be powered on via a USB cable, and it has some buttons on top of it, and this is just a small box. And why we call it Kelvin wallet? Because the limit of code is 0 Kelvin, and in order of 3 Kelvin. So what this cold wallet device can help us? It is just a small device that helps us confirm transactions. Whenever we want to perform some operations on the blockchain, maybe we want to withdraw a funds from account A and send it to account B, or maybe we want to execute some smart contract transaction code. Originally, we can just install some software on the PC, and the PC software will help us manage our own private key. Maybe it can help us encrypt the private keys using our own password, or it can use the trusted platform module or any other security element, hardware devices on our laptop to encrypt those things. And we will just use the software to perform the operation. However, there is a big risk that a complicated system like a PC, where in the operating system we install many software apps, there is a huge probability that there may be some malfunctioning apps that can leak our secret information, or we just accidentally install a malware on our device, and suddenly all our private information in the memory or in the disk are accessible to attackers. In order to prevent that, which is very hard, with such complicated system, we can actually delegate the storage and operation of all the private keys to a much simpler, much smaller device that we can audit, we can understand, such a small USB dongle. And when we want to perform the transaction, we just plug in the USB device or use the wireless Bluetooth connection to send the message. And this message, maybe over a USB cable, does not carry any credential information. And all the private keys will never leave this device. And here on the display, it can show the actual operation we are going to perform in order to prevent phishing attack. So that is what a cold wallet can do. And here is just a tech brief. We are not going to go into the detail, but this device, it supports the common standards to derive private keys for cryptocurrencies like Bitcoin, Ethereum, Ripple, and so on. And currently it supports some blockchain, including Ethereum, Bitcoin Litecoin, Bitcoin Cash, Ripple, and Tron. And we have open source a Node.js SDK on the GitHub, which is available under the organization Kelvin Wallet. And to use it, we need to install Node.js on our laptop or PC, and I will do a quick demo for this. Actually, for our internal development, we also have a Python API, but we haven't open sourced that yet. And here is some photo of how the device works. On the small device, the screen can display, okay, we are actually going to send how much amount of money to which account. And even when our PC, our laptop got attacked, maybe there is a malware running on our PC, so the display on our computer shows that, okay, I'm going to send maybe a Bitcoin to my mother, but under the hood, attacker is actually manipulating the message to send 10 Bitcoins to the attacker's account. And with the ability of what you see is what you sign features, just a display on the hardware, we can prevent most of that attack. And here I'm going to show you how does a cold wallet work. Because I'm going to show the device and my PC's display, so I'm going to do it like this. Okay, so this is a powered on cold wallet. Or maybe I should unplug it first. If we unplug the USB cable, it just shuts down immediately, and whenever we power it on, it will be welcomed with a screen that asking us to enter our own PIN number. And on this device, we have a few buttons on it, so we can select the digits like this. And I have set this up with the pin 0000, so we can just do so. The resolution is not very good. 0, and every digit will start it with a random 1, so that attacker who can listen to my click or who can see my hand motion cannot guess what digit I'm typing now. So I'm going to give 4 zeros and choose confirm. So that is the first user experience of most cold wallet. We will need to unlock it with our own authentication mechanism. Most of the time there will be a PIN mechanism. And some higher end products could have a fingerprint scanner on this device. And there we can see there are some navigation user interface on it. But most of the time I'm just going to open this wallet for operation from PC. And it is now saying that it is ready to approve transaction. And I'm going to do that. I'm going to initiate a transaction from PC. In order to do that, we need to talk to this device over the USB cable. And on Mac or on Windows, we can using the system built-in method to view that, okay, there is actually a device, USB HID device called Kelvin wallet here. And I have just installed this Kelvin JS SDK. So I'm just going to open my terminal and navigate to this repository. This is just the same repository on the GitHub. I just cloned it and installed it. And when we have our own device connected to the PC, I can do something like, oh, okay, maybe I can just check what can I do. This command line tool can help us interact with Kelvin wallet from the text terminal. and there are some actions we can perform. For example, in the README of this repository, here are some example comments. For example, we can query a public key number 1, public key number 2, public key number 3. We can query public key from the device. So let me do that. And it just query a public key from my device. And the public key looks like this, just some hexadecimal string. And we can convert such public key to convert or encode it into my own Ethereum address. So here I'm asking it to convert it encode it as an Ethereum address so that I can send Ethereum to this account. And for the purpose of demo, I already deposit some Ether into this address. We can see it on a public network blockchain explorer. This is very popular explorer for Ethereum called Etherscan. And I am on the Kelvin testnet, on which I don't need to actually spend my money to buy some Ether. So in this account, I have the balance of 0.499. So I can actually manipulate this account. So let's do a simple transaction. Maybe I want to send 0.1 Ether to another address. And to do that, I have prepared some test script. So in order to actually sign a transaction, we need to call Kelvin tool with this argument. So this comments here, I am calling the sign transaction function from the SDK, and there are some parameters. Here is the public key. The public key is just my account's public key. Filling public key here is to help the tool to check the account's state. And here I'm saying that I'm going to send my money to another account. Okay, actually let me change this. I'm going to send money to this address and the amount is 0.1. And I can choose how much fee I'm going to spend for this particular transaction. I'm saying that, okay, I can pay as much as 10 gigaway. The fee for Ethereum is the fee is the number of ethers or number of way per gas unit. And I'm just saying, okay, I can pay 10. So when I execute this operation here on the PC, we can see that, okay, I'm going to do this operation. I'm sending 0.1 Ether to another address. And also on the device side, also get the USB command and decode it and display all the detail on the display. So we can see the address. My address is 0xFF78. This is my own address, which I have some fonts. And I can navigate on this device. So I can press the button or press the button left or right to navigate. So I can, as we can see on the page number 2, it says that, okay, the amount to send is 0.1 Ether. And on the other page, we can also see the recipient of this transaction is 0x A60F and so on. And also there is a transaction fee. The transaction fee is 0.00021 because that is the actual Ether amount after multiplying the gas estimation. And nonce is just a technical account state, a technical term for for every Ethereum transaction. It means that this account of mine have performed 2 operations on the network, and actually this is the 3rd operation I'm going to do. So on the cold wallet device, we can press the middle button to confirm this transaction. It will ask us again, do we really want to confirm this transaction? And I can do that. But actually, because I have not been doing all the operation for a long time, so the operation already timed out on my PC side, I can do that again. So here I'm pressing sending the command, and the device receives the command. We can check the detail or confirm it using the UI. And after confirm the operation, the device signs the transaction and send it back to the PC. As we can see it here, this is a signed transaction for Ethereum, and we can just broadcast it using the command line, or we can also broadcast it using any web interface like this Explorer. We can see I want to broadcast a transaction, and I can just paste it here, send transaction. And okay, the transaction is successfully validated by this node, and we can check it later. It is already confirmed by the blockchain and will be included in this block. After that, and we can see if our address, if the balance of our own address actually gets updated. Okay, so it is actually updated. Originally it was 0.499, and now it is 0.399. So that is a typical routine, a typical workflow to sign a transaction using a cold wallet device. And also, on this device, I can demonstrate some other operations we can do. So here, I just unplug it and plug it in my PC again. So it is now showing the pin entry user interface. What if this device gets lost or gets stolen by some attacker? What can they do? So if I know the pin of this device, then actually it is done, because if I know the pin code of this device, it is very much like I know the pin code for an ATM card I got from other people. So I can just withdraw any money from it. And if I don't know the pin code, maybe I can try some pin code. So maybe I can just enter some random one and say yes. Okay, but because the pin code I just entered is incorrect, so it just says invalid pin. You have 2 attempts left. This is a very common strategy implemented by most security tokens, where the brute force attack is invisible because there are only a limited number of attempts available, or the number of seconds, the time it will take to validate your PIN will grow exponentially so that it is invisible to try too many PIN codes. Okay, so that's it. Do you guys have any question about cold wallet devices? If not, then this is this lecture.
I have a question. Is the wallet also separate for ERC20 and Tron and other like Tron's the TR20 protocol token? The Kelvin wallet is also separate for another blockchain, public blockchain, the smart contract.
Oh, this is a good question. Actually, as you can see, these cryptocurrencies and actually these two smart contract feature belong to Ethereum, and all these cryptocurrencies are based on transactions that can be signed by ECDSA algorithm. And currently, the publicly available firmware version, we support just these currencies. And for the token parts, because we need to, in order to support a special cryptocurrency token, native coin or token, we need to add a comment so that we can deserialize the request and construct the message to be signed and generate all the data structure that need to be shown on the display and generate response. So it is an ad hoc work to add a token or a cryptocurrency, and currently we only support this. But if we want to add new token or if we want to add new currencies, that should be very easy if the target blockchain also use ECDSA. Yeah, and this is the current status of such device.
Thank you.
Does anybody have other questions? If not, then this is the lecture, and thank you very much. And if you have any other question, you can come here and see. We can talk about this.